Hello, friends. Welcome to Brilliant Mind Scholars. On our lectures today, we're going to be dealing with a very exciting concept termed complex numbers. Now, what really would complex numbers be? Complex numbers are numbers expressed in the form a plus a plus bi. This would be a classic example of what a complex number would be, where a is a real number and b is also a real number, right? But I is the imaginary number, and I would be the solution to the equation x squared plus 1 equal to 0. X squared plus 1 equal to 0. Now, attempting to solve this equation, we have that x squared would be equal to minus 1, right? And in solving this further, we have to take the root of both sides. This gives us the root of x squared and the root of minus 1. Now, taking the root on the left hand side, we have that the root of x squared becomes x. This becomes x, and also the root on the right hand side. Now notice now that we cannot really find the root of negative 1, right? As such, we have that the root there becomes plus or minus roots minus 1. This is what we're going to have in this form. Now, because we can't really find the root now of negative numbers such as negative 1, the root of negative 1 now becomes imaginary, and as such we equate it to I, such that you're going to have that I would be equals to the root now of minus 1. This is what we're going to have in this form. As such, imaginary numbers now are numbers which we cannot really find a solution for. We cannot really find a solution for, right? And I now represents the root of minus 1. Now, conventionally now, we are usually told to find the higher powers or higher exponents of I. We just said now that I is equal to the root of negative 1, right? Suppose you are asked now to find I squared. How do we go about this whole piece? Now, notice now that we said that I on its own now will be equal to the root of minus 1, right? So it means that I squared would be the root of minus 1 all squared, the root of minus 1 all squared. And notice now that this square cancels this square root, right? And as such, I squared becomes minus 1. I squared would be minus 1. Also, you could also be asked to find I raised to power 3 or I cube, I raised to power 3 or I cube. Now, a sound knowledge of the concept of indices would help us here. How is that? Because we are going to be evaluating some variables now with our knowledge on indices. Now, we have a video on the topic indices now. Do well to check our playlist and you see some of those videos there. Now, I raised to power 3 now would be, notice now from our knowledge in indices that I raised to power 3 can also be rewritten as I raised to power 2 times I raised to power 1, right? How is this? Because 2 plus 1 as the powers there, right, would give us 3. Notice now that from our knowledge in indices, right, when we have similar bases, we can just simply add up the powers. When we have similar bases, we can simply add up the powers. Do well to check our playlist and you'll find the video on indices so that you can understand this topic better. Now, in doing this now, notice now that I squared we got to be minus 1. I'll quickly write minus 1 here. We got I squared to be minus 1, and I raised to power 1 is the same thing as I, right? So I raised to power 1 is the same thing as I, and in complex numbers it is conventional to write I just the exact same way it is. We don't have to always write root 1. So it means that I raised to power 3 gives us minus 1 times I, minus 1 times I. So minus 1 times I would would give us minus I. As such, I raised to power 3 gives us minus I. So we have it that I square would give us minus 1, and I raised to power 3 or I cube would give us minus I. Now suppose we are asked to find I raised to power 4. I raised to power 4. How do we evaluate this whole piece? We're still going to have to use the knowledge, right, of indices to evaluate this. I raised to power 4 can also be rewritten as I raised to power 2 times I raised to power 2. How is this? Because 2 plus 2 as the power there would give us 4, right? Because we can simply add up the powers when our bases are the same. And in this case now, our bases are the same. We have I and I at the base. Now, from our previous calculations now, we got that I square would give us minus 1, and also I square will still give us minus 1. And as such, we have minus 1 times minus 1, and this gives us 1. Minus 1 times minus 1 will give us positive 1, right? So we can also write 1 in that case. Suppose we are asked to find I raised to power 5. I raised to power 5. So your guess is as good as mine, right? We can choose to rewrite this as I raised to power 3 times I raised to power 2. Now someone will be thinking, oh, I raised to power 5 can also still be written as I raised to power 4 times I raised to power 1, right? Yes, you are also correct, right? As long as you have a sound knowledge on indices, you will be able to evaluate this whole piece. You'll be able to play with these variables whichever way you want, and you will still arrive at the same answer. Now, I raised to power 3 now, we have gotten from our studies to be minus I, and I raised to power 2 now, we have gotten from our studies to be minus 1. So this will be minus I times minus 1. How true, very true, very true. Now, minus I times minus 1, minus times minus gives us plus, right? So as a result, our answer for I raised to power 5 would be I. How true, very true. Let's do this up to I raised to power 10. Then I'll show you a little trick in which you can use to solve this without having to go through the rigors of all this calculation, right? I raised to power 6 now. I raised to power 6. We can choose to rewrite this as I raised to power 4 times I raised to power 2, right? Whichever way you can choose to do it. You know, and like I said before, you can play with it in whichever way you like. Because I raised to power 6 now can also be written as I raised to power 3 times I raised to power 3, right? It can also be written as I raised to power 5 times I raised to power 1, right? So whichever way you can understand it, whichever way you choose to evaluate it, you will still arrive at the same answer as long as your knowledge on indices is sound, right? Now, in this case, I choose to use I raised to power 6 now. I choose to rewrite it as I raised to power 4 times I raised to power 2. Very true, very true. And notice now from our studies, I raised to power 4 gives us 1, and I raised to power 2 would give us minus 1. Right? Very true, very true. Now, in the aftermath, right? In the aftermath, 1 times minus 1 would give us minus 1. So I raised to power 6 now, wherever and whenever you see I raised to power 6, it will always give you minus 1. How true, very true. Okay, quickly moving on. I raised to power 7. I raised to power 7. Now, I raised to power 7 we can choose to rewrite as I raised to power 4 times I raised to power 3. So this gives us I raised to power 4 times I raised to power 3. Very true, very true. So we know that I raised to power 4 is 1, and I raised to power 3 now would be minus I. So that will give us 1 times minus I. How true, very true. So in this case now, 1 times minus I will give us minus I. How true, very true, very true. Now I raised to power 8. I raised to power 8. We can choose to rewrite that as I raised to power 4 times I raised to power 4, right? Yes, indices. So I raised to power 4 times I raised to power 4. So in the aftermath, right, we know from our studies that I raised to power 4 gives us 1, right? I raised to power 4 gives us 1. That would be 1 times 1. 1 times 1. And in the aftermath, right, this would give us 1. How true, very true. Now, I raised to power 9. For simplicity, I'll write that as I raised to power 5 times I raised to power 4, right? So I raised to power 5 times I raised to power 4. This would be 4. Let's rewrite that properly. Now, so I raised to power 5 we got to be I. And I raised to power 4 we know would be 1. So that would be I times 1. 1. And in the aftermath, right, I times 1 would always give us I. Very true, very true. Lastly, I raised to power 10. Oh, I sincerely do hope I have enough space here. So I raised to power 10. I raised to power 10 now will give us I raised to power 5 times I raised to power 5, right? So we have I raised to power 5. Let me move this upward. We will not have enough space to work here. So we have I raised to power 10 gives us I raised to power 5 times I raised to power 5. How true, very true. And we know that from our previous calculations now, I raised to power 5 gives us I, right? Very true. And I raised to power 5 would also give us I. So that would be I times I. Now, this gives us I times I would give us I squared, right? Very true, I squared. But we can simplify this further, right? And in the aftermath, I raised to power 10 will give us minus 1. How is this? I times I now would give us I squared. So we have I squared. But notice now that I squared from our studies gives us minus 1. Minus 1. So in the aftermath, we have that our final answer for I raised to power 10 will give us minus 1. How true, very true. Okay, now here is my trick. Now notice now that some of these values can begin to repeat themselves, right? So I want to teach you a little trick that you can always use to find some of these variables without the rigors of calculation so much. Now notice now that I raised to power 5 is the same value as I raised to power 1. So it means that wherever we see I raised to power 5, we can substitute the value for I raised to power 1, right? So notice now that I raised to power 5 is I. Now, so whenever we get to I raised to power 4, I raised to power 4 serves as a landmark. Whenever we get there, we begin to count again from the top. So I raised to power 5 becomes the same value as I raised to power 1, and I raised to power 6 now will give us the same value as I raised to power 2. So notice now from our calculations now, we got that I raised to power 6 here gave us minus 1, and I raised to power 2 is also minus 1. So we continue like that in that manner, right? So I raised to power 7 would be the same value as I raised to power 3. Notice now that we got I raised to power 7 to be minus I, right? And I raised to power 3 is also minus I. Also, I raised to power 8 now would also give us the same value that we have for I raised to power 4, right? This pattern continues in like that. So this pattern continues in that manner, such that when we get to I raised to power 4, we can begin to count again from the top. So I raised to power 9 now will be the same value as I raised to power 1. So I raised to power 9 we calculated to give us I. And I raised to power 10 now. I raised to power 10 now will be the same value as I raised to power 2. So notice now that when we're calculating, we got that I raised to power 10 give us minus 1, and I raised to power 2 is also minus 1. So this trend continues in that manner, right? So that I raised to power 3 will be the same value as I raised to power 11, and I raised to power 12 will be the same value as I raised to power 4. I raised to power 4. So there you have it, guys. You can continue this pattern, right? You can use this pattern now to solve most of your equations, most of your exponents now of I, right? So if I ask you to find I raised to power 20, you can simply count down from I raised to power 1 down to I raised to power 4 to get your answer for that variable. Here are these questions, right? So you're going to solve these questions and leave your answers in the comment section. Now, first of all, you're going to find I raised to power 27, then you find I raised to power 30, and the third one is a bit easy. You have to find I raised to power 19. Thank you so much for watching. See you in the next video. Now, in the next video, we're going to be solving more questions relating to higher exponents of the complex numbers.